morning. Myself Nidhi Ghetia from Faculty of Pharmacy, Dr. Subhas Technical Campus. Today's our study of the subject that is Pharmaceutical Organic Chemistry 1, that's called is BP 202 TP. Okay, so in this subject we learn our third chapter, that is alkenes. Okay, so in alkenes we study our next topic, that is chemical properties of the alkenes. Okay, so chemical reaction, which are the chemical reaction occurs in the alkenes that we see. Okay, so first chemical property, that is electrophilic addition reaction. Okay, electrophilic addition reaction, like electrophiles are attack on any one atom and bonded with the that atom. Okay, so addition of the any one electron. Okay, so that's called the electrophilic addition reaction. So alkenes, so the electrophilic addition reaction in which one weak pi bond is broken and two strong sigma bond are formed. Okay, so in this reaction one weak pi bond are break. Okay, pi bond are the break and generation of the other two sigma bonds. So in electrophilic addition reaction, and then the overall reaction involves the release about 443 kilojoule prati mole of the energy. Okay, this much energy are required in this reaction. Okay, so during this addition reaction, the attack of the pi electrons of the double bond occurs on the electrophile, leading to the formation of the carbocation, which are intermediate. Okay, so formation of the carbocation in intermediate in pi electron are attack on the double bonds. Okay, so electrophiles leading and formation of the carbocation atom. And then rate of the addition depends upon the stability of the carbocation. Okay, then greater the stability of the carbocation, more reactivity of the alkene. Okay, so greater the stability of the cations, carbocation are new formed, generation of the carbocation at the intermediate product, so that stability are the better and more the reactivity of the alkenes. Okay, so now we see the reaction. So in this we take the alkene plus one electrophile attack. Okay, so generation of the carbocation. One electrophile are add one other carbon and plus charge cation of charge are also attached in a other carbon. This is a mechanism of electrophilic addition reaction. Okay, now we see the mechanism. So for an example, Br2 to ethylene. Okay, so we takes the ethene plus Br2 as a electrophile atom. Okay, in the presence of CCl4, they generates the 1,2 dibromoethane. Okay, Br2 attack on the CC ethane. So generation of the dibromoethane. Now first step, two-step mechanism. So in the first step, bromine itself is a non-polar, but pi electrons of the double bond are repelled to electron pair of the two bromine atoms and make the polarize. Okay, so polarize, its bromine are itself non-polar substance atom, and pi electron of the double bonds are repelled to the electron pairs. Okay, so bromine are attached with the other atoms and generation of bromine are converted in a polarized system. Okay, so this step is slow. This bromine to making a carbocation, this step is a slowly. Okay, so in this bromine are interacted with ethylene and polarized bromine molecule are converted because it's having a charge. Okay, first non-polar bromines are not having any charge, and after the reaction with the ethylene, bromine having a charge. Okay, then that's converted in a polarized bromine molecule. Or ethene plus Br attack on the ethene and making the one Br attached with the ethane and one Br liberated. Okay, so this is a step 1 mechanism, and now step 2 mechanism. So the carbocation are formed in step 1 and undergoes the nucleophile attack by the bromide ion form addition product. Okay, so another carbocation are formed and one bromide are liberated. So that bromide are also attached with the ethane and making the 1,2-dibromoethane. This step is a fast because the nucleophile attack on the atoms. Okay, so this step is a fast and making the 1,2-dibromoethane. So this is a first electrophilic addition reaction. Now second reaction, that is the addition of the halogen acid. Okay, so in this reaction, when alkenes react with the halogen acid like HCl, HBr and HI. HCl means hydrochloride acid, HBr means hydrobromide and HI means hydrogen iodide. Okay, so alkyl halide is formed in we takes the alkene plus HX, that is a halogen acid. Okay, now halogen acid are attached with the alkenes and making the alkyl halide group. Okay, so this order of the reactivity of the halogen acid like HI greater than HBr greater than HCl. Okay, then the final product formed depends upon the whether the alkene is symmetrically or unsymmetrically. Now we study the first addition of the symmetrically alkene. Okay, so when alkene is symmetrically, only one product is formed like ethane plus HBr. HBr, that is a hydrogen bromide, halogen acid. Okay, and then hydrogen Br are attached with the ethene and make the generation of the bromoethane. And then second reaction, that is the addition of the unsymmetrical alkane. Okay, so in this, when alkane is unsymmetrical, then two products are possible to form. First, we takes the propene plus HBr. In a dark environment, absence of the peroxide and generation of the two products, that is 2-bromopropane, that is major product, and 1-bromopropane, that is minor product. Okay, so 2-bromopropane is a 80% chances formed and 1-bromopropane is a 20% chances formed. So major product is a more stable to minor product. Okay. Now study of the Markovnikov rule. In 1869, Russian chemist, that is Markovnikov, gives this rule which states that the addition of the unsymmetrical reagent such as HX, H2O or HOX etc. to unsymmetrical alkenes occurs in such a way that the negative part of the adding molecule goes to the carbon atoms. Okay, and of the double bond which carries the lesser number of the hydrogen atoms. So in this statement, addition of the unsymmetrical reagents. In this addition of the unsymmetrical reagent like halogen acids or H2O or HOX. Okay, so two unsymmetrical reagents are addition and making the alkenes occurs, and reaction with the alkene and making the one substituted alkenes. Okay, so here we take the 2-methyl propane, one carbocation are already generated in 2-methyl propane plus HCl. Okay, so Cl are attached with the propene and making the 2-chloro-2-methyl propane. Okay. Now that's explanation. The addition of the HBr to propane occurs in a two-step. First, that is if proton add addition on the terminal carbon, an atom of the double bond and secondary carbocation are formed. So first propene plus H plus that is a cation formation. Okay, then first cation, that is terminal carbon in middle carbon. Okay, second number carbon. So secondary carbocation are generated and Br minus and Br are attached with the 2-bromo second number terminal position. Okay, so making the 2-bromopropane and that is a major product. Okay. So, since secondary carbocation is more stable than the readily undergoes the nucleophile attacks, and by Br minus ion to forms the 2-bromopropane in is a major product. Okay, so in this reaction, we first take the propene plus H plus ion addition. Reaction with both are reacted and making the one carbocation. So in this carbon cation, double bond are converted in a single bond. Okay, and H plus are attached with the carbon. One carbon. Cation are attached with the one second number terminal carbon. And after the formation of the secondary carbocation, and one Br molecule are attack on the molecule and making the 2-bromopropane. Okay, that is a major product and more stable. Then second one rule, that is if the addition of the proton occurs on the middle carbon atom and formation of the primary carbocation. Okay, so propane plus H plus ion. Okay, we take the propene plus H plus ion, and after the reaction, generation of the primary carbocation and bromine are further reaction with bromine, and bromine are attached with the last number carbon, that is first number carbon. So that's name is a 1-bromopropane, and this product is a minor product. Okay, so less stable. This product is a less stable. Okay, now we study the anti-Marconic rule, that's also called as a peroxide effect. So the addition of the HBr to unsymmetrical alkene take place the contrary to Marconic's rule in presence of the peroxide such as the benzyl peroxide, and this is known as a Kharas effect or also known as a peroxide effect. So in this reaction, we take first alkene plus unsymmetrical alkene plus HBr. Okay, so HBr, that is a electrophile. In the presence of this reaction are follows in the presence of benzyl peroxide, any peroxide rule. Okay, the Marconic rule in presence of the Marconic rule are follows in the presence of the benzyl peroxides. So that's called the peroxide effect, either Kharas effect. Okay, so propene plus HBr in the presence reacted with in the presence of benzyl peroxide, that is C6H5COO. Okay, and 2 moles of the benzyl peroxide and CH3CH2CH2Br. Okay, so that's naming, that is a 1-bromopropane. Propane, and mechanism it follows this reaction follows the 3-step mechanism. First one, that is the initiation, second one, that is a propagation, and third one, that is a termination. Okay, so this first initiation, that is a starting product or material we take in a reaction, and then second one, that is a propagation, that is a intermediate products. Okay, and then termination, that is the last step of the our reaction. Okay, so thank you to all.